Hello, and welcome to today's UCL Connect event, How Lifestyle Shapes Brain Health and Cognitive Function. My name is Lisa Yasamides, and I work in the Alumni Relations team at UCL. It's great to see so many of you here, and I'm really looking forward to hearing from our guest speaker today. For those of you who are new to the UCL Connect series, this event is part of a series that looks at improving the professional and personal development skills and expertise of alumni, students, and staff members across the global UCL community. So whatever stage of life you're in, the UCL Connect series has something for everyone. On the screen, you'll see a few examples of some of the previous sessions we have run. If you'd like to rewatch any of these, there is a URL at the bottom of the screen, and you will see that the program is a mix of virtual in-person events, and we run those around once a month during term time. Before we begin, I just wanted to let everyone know this event is being recorded. There will be an opportunity to ask some questions to our speaker. You can do this by writing your questions in the Q&A section, which you'll see at the bottom of the screen. So please put your questions in here at any point during the session. We'll come to those at the end. We have just over 200 people at the moment, it looks like, on the call. So unfortunately, that does mean we won't have a chance to answer everybody's questions. So it's really important that you use the upvote function to choose the questions that you'd most like to be answered, and we will defer to those ones first. If you would like to bring up live captions on your screen, these need to be individually turned on. To use the feature, you will see a button that has 3 dots and the word more at the bottom of your screen. If you click that button and then the word captions, followed by the option that says show captions, that feature will be enabled for you. So what you can expect from today's session. So our speaker, Mikaela Bloomberg, will begin with a presentation and followed by questions from you. So with that all wrapped up now, I'm really delighted to welcome today's speaker, Mikaela Bloomberg, PhD, who is not only a UCL alum, but also Senior Research Fellow in Social Epidemiology and Social Statistics at UCL. Thank you so much, Mikaela. Over to you.
Thanks very much. So as Lisa said, my name is Mikaela Bloomberg. I'm a Senior Research Fellow in the Department of Epidemiology and Public Health here at UCL. And I'm part of the English Longitudinal Study of Aging study team, which is a large-scale and long-running study on health and aging, where I do work primarily on cognitive aging. So I'm going to go ahead and share my screen. Okay, today's talk is entitled How Lifestyle Shapes Brain Health and Cognitive Function. So this aim of this talk is to give a very high-level introduction to cognitive aging and the role that aging might play in cognitive health. So I won't be going into too much detail today, but I do hope it will give you sort of a helpful overview and a jumping off point if you're interested in the subject. And I'll also cover some of the most important things to be aware of in this area of research, which will hopefully help you a bit as you see this research covered in the media. Okay, so here is what I plan to cover in this talk today. So to start with, I'll introduce the idea of cognitive aging and brain aging. I'll then move on to talking about what we know about relationships between lifestyle factors and cognitive health and some of the mechanisms that might underlie some of those relationships. I'll then briefly cover what aspects of cognitive health we can try to change and those we can't. And finally, I'll give a couple of practical takeaways. Okay, so right on to cognitive aging. So before fully jumping into cognitive aging, I need to explain specifically what I mean when I say cognitive function. So cognitive function in general refers to those abilities that are used to process data in the real world. And we organize them into cognitive domains, which comprise similar abilities. So these include basic perceptual abilities, things like visual perception, or even things like motor skills, and more complex abilities like language, vocabulary, or memory, all the way up to probably what is among the most complex of these cognitive domains, executive function. And this is all those functions relating to planning and decision making, and it involves the coordination of many different cognitive domains. In practice, of course, there's a lot of overlap between these domains, but one of the reasons it's helpful to sort of conceptualize them separately like this is because then we can design tests to measure them for research and clinical purposes. So we use these short puzzles, reaction time tasks, recall tasks to measure different cognitive domains. And we do this in our research to measure how people's cognitive function changes over time with age. Or in a clinical setting, we might use them to evaluate cognitive impairment as part of a dementia assessment. So here are some examples of some of these tasks. On the left, this is called the cancellation task. In this task, you'd be given a specific shape and told to cross it out. So in this particular example, the instruction is to draw a double line through the X's. So you'd be scored on how many shapes you correctly canceled out and your speed. So this is an attention and a processing speed task. On the right is the trail making test. So it might be a little bit difficult to see, but there are actually little numbers in each of those circles. You'd be asked to draw a line through the numbers in the correct sequence. And once again, you'd be scored on accuracy and speed, which tests executive function and processing speed respectively. So they are these very simple tasks, but they can be these very powerful tools to reveal how well we are doing cognitively speaking. So if we administer these tests multiple times over the years, we can get an idea of cognitive aging. And so this just refers to the change in cognitive function with age. So in this little plot, we see that as age along the bottom increases, there is a decrease in cognitive function. And this is true across many different cognitive domains, including things like memory, processing speed, and executive function. And indeed, in general, with age, we see that cognitive abilities decline a bit, and it is completely normal. It doesn't mean that there's something necessarily wrong. And there are even some cognitive abilities that actually tend to improve with age. So things like vocabulary tend to actually remain stable or even get a little bit better as we get older. So the way that these cognitive abilities change with age is domain specific, and it also varies a lot between people. So there's a huge amount of variation in so-called normal cognitive aging, that is normal aging related cognitive decline that is not occurring due to a neurocognitive disease like dementia. It's important to keep in mind throughout this presentation that experiences of cognitive aging are highly individual and no two cognitive trajectories will be identical. So we've talked a little bit about cognitive aging, but how is this connected to brain aging? When we talk about brain aging, we're referring to structural changes in the brain as we get older. So this can include things like loss of brain cells, the shrinkage of certain structures in the brain. Whereas cognitive aging is how well the brain actually functions during aging. So it's how well things like memory or attention or processing speed are maintained. And importantly, brain aging contributes to cognitive aging, but they do not always move in lockstep. So just because we see a loss in the volume of brain structures or we see nerve cell loss does not mean we see commensurate cognitive decline. And that's because the brain has this ability to compensate for changes to its structure so that they do not necessarily change your ability to function. So the brain can find these sort of workarounds or recruit other networks as it ages, so that even if brain structures are training or changing, you can still keep functioning at the same or a similar level. And in that way, older brains are often more sort of efficient than younger brains. So in that they're often doing the same with less. And the ability to recruit these compensatory networks is very individual as well. So the extent to which different people can develop these sort of workarounds differs quite a bit. So this might seem a bit of an obvious question, but why is it so important to maintain our cognitive abilities as we age? Of course, because cognitive aging dictates how well we function on a day-to-day basis as we get older. Even though normal cognitive aging shouldn't involve severe impairment to the ability to do day-to-day tasks, if we have faster cognitive aging, that is, our cognitive abilities decline more quickly, even within the realm of normal aging, we might see things like reduced independence and social participation, which could impact our quality of life. The other reason to try to slow cognitive aging is because, quote unquote, faster than normal cognitive decline during aging, that is, decline that is faster than the normal aging related changes that we'd expect, is one of the primary symptoms of dementia. And dementia is a syndrome. This means that it's a collection of symptoms. And the main one of these is cognitive impairment that is severe enough to impact day-to-day functioning. So that means cognitive impairment to your cognitive function that is starting to impact your ability to do basic tasks like feeding yourself or taking medication. And there are several different what are called dementia etiologies, which means different causes of dementia, which can have slightly different symptoms and usually have different characteristics when we do brain scans, which can help with the diagnosis. So the first one, which I think will be the most familiar to people, is Alzheimer's disease. This is the most common dementia etiology, and it's characterized by this abnormal buildup of proteins in the brain. The second most common etiology is called vascular dementia, and this has to do with damage to the small blood vessels in the brain. So these together, Alzheimer's disease and vascular dementia, account for the vast majority of dementia cases. And we also have some less common etiologies below. So there's things like Lewy body dementia, frontotemporal dementia. This is the one that often causes sort of dramatic personality changes, though all can to some extent, and other dementias that are caused by other diseases, for example, like Huntington's disease or Parkinson's. So in practice, a lot of times dementia is of mixed etiology, which is to say that it might have some features of different diseases. So for example, an individual might have primarily Alzheimer's disease characteristics, but have some vascular features as well. So a lot of your risk for dementia is caused by things that are outside of our control, things like genetics and family history. But the reassuring thing is that we think up to 40% of dementia cases are attributable to modifiable risk factors, that is, things that we do have control over. So every couple of years, there is a Lancet Commission, which is one of the major medical journals, and it's a report that summarizes determinants of dementia, which includes summarizing the evidence for modifiable risk factors for dementia, or those factors that are within our ability to change. So this graphic shows the major findings from the most recent report, which came out in 2024. It shows the risk factor and then the percentage of dementia cases that might be eliminated if we could remove that risk factor. So, for example, 2% of dementia cases are thought to be attributable to smoking. So, if we magically made it so that no one smokes anymore, hypothetically, we could reduce the number of dementia cases by 2%. Now, that might not sound like very much, but in the UK, that equates to around 20,000 dementia cases. And another thing to note here is that dementia prevention is a lifelong goal. So, we start with education early in life, we move through these midlife risk factors that are primarily related to health and lifestyle, and then into late life, which includes things like air pollution and visual impairment. At multiple points along the life course, though, there are opportunities for intervention. So the question is then, how does sort of normal cognitive aging fit into all of this? So why might we want to study cognitive aging when we are primarily interested in dementia prevention? So this plot shows a cognitive trajectory, that is how cognitive function changes with age, which is this gray line that we see decreasing as the age increases. So the idea is if your cognitive abilities decline enough, you reach some threshold where it starts to impact your ability to function. And then you might seek out a dementia diagnosis. So that's this threshold, which is represented by the dashed orange line. But the fact is, your cognitive trajectory doesn't suddenly just begin at decline. You actually have decades before your cognitive function starts to decline, because we know cognitive function sort of peaks around midlife, sort of plateaus for a while, and before it starts to decline. But let's say, what if you intervene on an early life exposure? So let's say you happen to have a better quality education, you're able to get a higher degree. What that might mean is your peak cognitive function is higher during midlife. So that sort of plateau phase is higher. So even though you have the exact same rate of decline as you did before, you are now starting from a higher point. And the effect is that you don't necessarily end up crossing that threshold where cognitive impairment impacts your day-to-day life, or you cross it at an older age. So that's one way that these sort of modifiable risk factors might impact your dementia risk just by affecting your cognitive aging trajectory. But there's another way too. So let's say we have two people with cognitive trajectories here that are represented by the dashed line and the solid line. And they have very similar early life experiences, and they end up with kind of similar cognitive function at midlife. Their plateaus are very similar. But let's say, for example, one is a smoker and one isn't. What we might see then is very different rates of decline. So even though they started from the same place and had a similar cognitive ability during midlife, one declines much faster than the other. And as a result, one person hits the threshold for cognitive impairment that would then potentially warrant a dementia diagnosis, and the other doesn't, even though they would have had similar cognitive function during midlife. So the point is that a modifiable risk factor like smoking or education can impact a dementia diagnosis either by improving midlife cognitive function or potentially by reducing the rate of decline. Okay, so there's an important caveat to all this, which might slightly contradict the previous couple of slides. Normal cognitive aging is not just quote unquote slower dementia. Dementia is not an inevitable consequence of aging, and it is not that if we lived long enough, we would all decline to the point of dementia, because many people live to their 90s or older with minimal cognitive changes. And that's because aging-related cognitive decline and disease-related cognitive decline are distinct processes. So, but there is overlap, and the brain is very complex. So, for example, a lot of people will have the hallmarks of Alzheimer's disease in their brain, and they'll never show any cognitive symptoms. They'll not have the same kind of cognitive decline. Our brains are very resilient and they're individual, and it's not a straightforward relationship between disease and cognitive aging and cognitive decline. That said, if we begin disease-related cognitive decline from as high of a starting point as possible, we can potentially prolong the cognitively healthy years that we have. So while we can and we do study cognitive aging to understand dementia, we really do have to study both to fully understand how we might intervene on cognitive health. Okay, so with that introduction to cognitive aging and dementia out of the way, let's move on to lifestyle factors for cognitive health and some of the pathways that might underlie these relationships. So once again, here are the modifiable risk factors for dementia. So of these, the Lancet Commission identified 4 that can be considered lifestyle factors. These include smoking, physical activity, alcohol consumption, and social isolation. So together, these factors are thought to account for about 10% of dementia cases. In the UK, that is around 100,000 dementia cases. So the contribution of lifestyle is pretty substantial. And if we hone in on these lifestyle factors, they include physical activity, and I'm going to add sleep to that, in part because it's very closely related to physical activity, though it is linked to cognitive health on its own. The relationship between sleep, physical activity, and cognitive function is a little bit more complex because sleep disruption is a notable early dementia symptom, which makes it difficult to study. I'll go into that in some more detail later on. But those quibbles aside, the other modifiable risk factors we have the most evidence for are alcohol consumption, smoking, and social isolation. So in general, we see that more physical activity, and here physical activity refers to both structured exercise, like going to the gym, but also any movement you do on a day-to-day basis, like walking to work. Good quality sleep and less social isolation have all been associated with a reduced risk of dementia, and in many cases, reduced rate of cognitive decline as well. The reduced rate of decline is seen primarily for sleep and physical activity. We also see excessive alcohol consumption and smoking have been linked to an increased risk of dementia and faster cognitive decline, though the most robust link is with smoking, and smoking is probably the lifestyle factor with among the most robust and consistent links to cognitive health. And I'm going to add one more lifestyle factor here, which is diet. Now, I include this with a bit of an asterisk because the strength of the evidence for specific foods is relatively weak. But in general, having a diet that is characterized by plenty of whole grains, vegetables, fruit is certainly beneficial for cognitive health. And diet is, of course, related to obesity, which is included in the Lancet Commission findings, but is not in itself exactly a lifestyle factor. Now, in general, these relationships with lifestyle factors are sort of what you'd expect. It's healthy physical activity and sleep patterns, eat healthily, don't smoke, don't drink too much. It's not overly surprising. But what I want to get into a little bit more is how these lifestyle factors might impact your cognitive health. And these relationships are very complex and oftentimes not fully understood. But there are a couple of pathways that come up over and over again that I want to share. So the first is cardiovascular and metabolic health. So this refers to heart health and things like diabetes and obesity. The second is a stress response, which is very helpful from an evolutionary perspective, but has some drawbacks because of the way our modern lives are set up, which tends to mean we are in a state of constant stress. And the next is the inflammatory or immune response. This refers to the body's innate ability to fight off injury and infection. And this is once again very helpful when occasionally triggered, but bad if constantly triggered. And finally, the direct effects of some of these, the direct effects some of these lifestyle factors might have on the brain. Okay, so I'd like to start off with cardiovascular and metabolic health. So there is an adage that what's good for your heart is good for your brain. And this cardiovascular and metabolic pathway is one of the most important for cognitive health. And many, many risk factors for dementia are thought to act through this pathway. So the way it works is that cardiovascular and metabolic diseases, things like heart disease, high blood pressure, type 2 diabetes, and obesity, cause damage to blood vessels, including those in the brain. When the small vessels in the brain are damaged, it's referred to as a cerebral small vessel disease. And this is a major risk factor for stroke and silent strokes, which are these sort of mini strokes that aren't able to be detected even necessarily, that can both damage brain structures and then can cause cognitive decline. So which of the lifestyle factors are most likely to act through this pathway? So the lifestyle factors that probably most directly act through this pathway are physical activity. As we know, exercise is very good for staving off cardiovascular disease and can prevent obesity and diabetes. Smoking, which of course can lead to cardiovascular disease, and a healthy diet, which once again is implicated in heart disease, obesity, and diabetes. But in practice, many lifestyles and general modifiable risk factors for cognitive health in general act through this pathway. Even the other pathways I'll discuss oftentimes point back to this cardiovascular pathway. So with that, let's move on to the next pathway here, which is the stress pathway. So the stress response is also called the HPA axis. And what happens is in this response is in response to a threat, it triggers this cascade in your body, which leads to a lot of different changes that are meant to prepare your body to face that threat. So your heart might start racing, you might start sweating. And while this is going on, a lot of different stress hormones are being released. And our stress response is meant to help deal with immediate challenges, and it's very good at doing that. The issue is when the switch stays on and we end up in the situation of constant stress. And this is what we call chronic stress, when we're constantly being flooded by these stress hormones. And it has this cascading effect where it can cause elevated blood pressure, disrupt our immune function, and impact things like sleep. And as we know, all these things can affect your heart and your metabolic health, which can then affect your cognitive function. And the trickiest thing here is that it's all a bit of a feedback loop. So your disrupted sleep and immune system feedback to produce more stress, which exacerbates this response. So you end up in this loop of worsening stress and your body responding to that stress with more stress. So lifestyle factors can, to an extent, interrupt the stress response. So while in the short term, exercise might cause you to actually release stress hormones, in the long term, it is thought to buffer that stress response a little bit and make it so that you release less of that stress hormone in general. Deep sleep sort of resets the stress response, and social support can actually reduce how much you perceive stress. So in this way, we can use lifestyle to moderate our stress response and potentially improve cognitive health. Okay, so if we move right along to the inflammatory response. So inflammation is the body's first line defense system, and it's part of what's called the innate immune response. So it is the non-specific response of the body to any injury or infection. And inflammation is the reason if you get a cut, for example, it will get swollen and red. It's increasing blood flow, recruiting immune cells to the spot to get to work to fix the injury. And in the short term, like stress, it's protective. The purpose of inflammation is to mobilize the immune system to fix the problem. The issue arises when, like stress, that system doesn't fully shut off. So when inflammation is constant, it can lead to damage to blood vessels and organs. And it's now thought that systemic inflammation, so inflammation outside the brain, can actually reach the brain, which causes something called neuroinflammation. And this can cause direct damage to brain cells. And there is actually a lot of work being done currently about the contribution of neuroinflammation to Alzheimer's disease. And it's thought to potentially play an important role. And all of this can cause damage to brain structures, which can lead to cognitive decline. So there are lifestyle factors that increase chronic inflammation, so the bad kind of inflammation. So they include things like heavy drinking, smoking, or a poor diet. But there are also lifestyle factors that are protective against inflammation, like physical activity and good sleep habits. So physical activity in particular actually increases inflammation in the short term, similar to stress, but it decreases chronic inflammation over time. And what these protective factors do is they regulate the immune system. So they make sure it responds when it's supposed to and it turns off when it's supposed to, because we don't want to suppress our immune function. We need it to fight off infection and injury, but we don't want it to be on all the time. Okay, so now I'll move on to this last pathway, which is direct brain effects. So some lifestyle factors might actually exert their effect directly on the brain rather than going through these cardiovascular stress or inflammatory pathways. So for example, there's this very well-studied short-term boost in cognitive performance occurring minutes or hours following physical activity, which could even last up to a day. And the reason for this is thought to be because there are these neurotransmitters, which are chemicals in the brain, that promote cognitive function that are released by exercise. It's also thought that long-term regular physical activity might preserve brain volume and connection. So it might stimulate neuroplasticity, which is to say the ability of the brain to adapt that I mentioned very early on in the slide about brain aging. And in that way, be protective against cognitive decline and dementia. And there are other behaviors that might directly damage the brain. So for instance, there is some evidence that alcohol or some of its byproducts are actually neurotoxic. So they directly damage brain cells. So I want to finish this all off with another important note about this area of research. So many relationships between lifestyle and cognitive health are bidirectional. So that is, lifestyle affects cognitive health and cognitive health affects lifestyle. And this makes study in this area very challenging. It's hard to know if we are seeing the effect of lifestyle on cognitive health or the effect of cognitive health on lifestyle. And we see that very much with physical activity. As people's cognitive function starts to decline, they do much less physical activity. So we might think that physical activity protects against decline, but really it's just that the people who are already declining are doing less physical activity. This is especially complicated because dementia symptoms can begin up to a decade before diagnosis. And some of the earliest some of the earliest symptoms can occur even before there's even sign of cognitive changes. So there was, for example, one study that showed 8 to 12 years before dementia diagnosis, physical activity patterns start to change. So that means that if we look at relationships between physical activity and dementia within that time, we're probably not seeing a protective effect of physical activity on dementia. We're seeing the effect of dementia on physical activity. So sleep is another one like this. Sleep disruptions are a well-established early symptom of Alzheimer's disease, but it's a feedback loop. So sleep disruption can go on and worsen cognitive symptoms, which can go on and worsen sleep disruption. So it's a bit of the chicken and the egg problem. Does poor sleep cause brain changes, or do brain changes cause poor sleep? So we do have a lot of different study designs that we use to try to tease out these problems. So we can have very long follow-up periods, for example, which means we might look at somebody's physical activity patterns in middle age, and then we might follow their cognitive decline for the next 20 years. And because we've assessed physical activity at a time when cognitive decline or any dementia symptoms probably haven't set in yet, we can be a little bit more confident that what we're seeing is the effect of physical activity on cognitive function and not vice versa. But this is always fundamentally an issue in this sort of research. And it's only in the last 5 years or so that we have a lot of these large scale studies with the length of follow-up that is needed to properly account for this issue. So this means we have to be careful when we read headlines that claim that something, quote unquote, causes dementia. So we have to read such headlines with suspicion and even go and try to find the original study if you're interested, because often the researchers have carefully presented the limitations of their work, but it does get simplified in the media. And the fact is, dementia and cognitive decline are complex, with complex and interrelated causes. The research is always evolving, but our understanding right now is that doing or not doing one single thing will never be the reason you do or do not get dementia. So be cautious of anyone who says otherwise, particularly if they're trying to sell you something. Okay, so all of that said, what can we actually change? So we can't change our age, genetics, or our family history. A lot of our cognitive fate is already prescribed. But what we can change and maintain is our lifestyle and our health. So we can develop healthy habits early on, we can maintain them as we age, and it's never too late to develop healthy habits. And while lifestyle certainly can't eliminate risk, it can sort of shift the odds in our favor. So I want to end with a couple of practical takeaways from this talk. First of all, cognitive aging is natural, but it's not fixed. So everyone has different experiences of cognitive aging, and no two people will have the same cognitive aging trajectory. And the evidence suggests we can, to an extent, modify our experiences of cognitive aging with healthy choices. Second, we know that small habits build up. So building a healthy lifestyle is building healthy habits one at a time as you can. There's work to suggest even just little bursts of physical activity, so running for the bus or going upstairs, could be helpful for our cardiovascular health as we age. So every little bit helps, and it's not all or nothing. And on that note, what's good for the heart is what's good for the brain. So looking after our heart health is looking after our brain and cognitive health. And finally, there are no magic fixes, but better odds. So we can't guarantee that any one choice will protect us against dementia or cognitive decline. We have to consider genetics. Sometimes we just get unlucky. But we can certainly shift the odds in our favor and make healthy aging more likely with small, healthy choices each day. Okay, so thank you very much for your time and attention. My contact information is there, and I will go ahead and have a look at the questions. Okay, so all right, so one of the first questions that's come up is, can you slow cognitive decline by maintaining a high level of mental activities into old age? Okay, so the evidence on this is tricky. So there's certainly evidence to suggest that you can sort of in the short term boost your cognitive performance based on sort of mental activities, sort of mentally stimulating activities. However, as to whether this will actually modify your long-term aging trajectory and reduce your dementia risk, it's not clear, and it seems to be not the case. Okay, so and the next question I see is, what do we know about the impact of increasing smartphone use on chronic stress and therefore function decline? So this isn't an area that I have a lot of expertise on, specifically smartphone use. I think because of the sort of salience of the stress pathway, anything that contributes to stress has the potential to contribute to cognitive decline. Yeah, so there's a question. Could you please recommend more accurate literature to keep learning about cognitive decline and aging? So in general, anything that comes out of some of the larger medical journals is a good resource. Things like the Lancet, BMJ. For lay resources, the WHO has good resources for maintaining cognitive health and aging. Things that sort of come from large health organizations, less sort of clickbaity kind of places. Let's see. Yep. So there's a question about B12 deficiency in relationship to cognitive decline. So this is definitely a growing area of research. As I said in the talk, evidence for specific contributions of specific sort of nutrients or foods to cognitive decline and dementia is still relatively mixed, but it's definitely an emerging area. It's a difficult area to study because it's hard to know. There's so many things that could affect diet and cognitive aging. So things about like your social class kind of things can affect diet and cognitive aging. So it's really hard to isolate the effects of diet on cognitive aging, which is why a lot of the research in that area is a little bit harder to hone in on. Yep. So there's another question about specific nutrients that are good for maintaining brain health. So yeah, so it's a challenging area of research, and research is sort of ever evolving for that reason, because it's hard to hone in on a true effect of a nutrient on cognitive decline. So I would say just in general, a healthy diet is a good thing, but I can't sort of authoritatively say that there's a specific food that should be eaten or something like that. So there is evidence about resistance training that it is it's useful for obviously cardiovascular health and for cognitive aging and day-to-day cognitive function as well. It can be very protective. The question was, you stated that exercising for cardiovascular health also helps slow cognitive aging. How about strength training? And the next question I see is sex differences in cognitive aging, and that's a really, really interesting one and a really long, long answer. So there's a pretty consistently observed sex difference in dementia risk, where we see that women are at higher risk of dementia, and there's a lot of reasons this could be true. It could just be that women tend to live longer than men. It also could be because there's estrogen, basically these sex hormones are protective against cognitive decline. So we see estrogen sort of drops very abruptly during menopause versus testosterone, which sort of declines at a steadier rate. But that said, we do not see consistent differences in actual rate of cognitive aging across different cognitive declines. We see that they tend to be pretty similar and they sort of flip-flop a bit between studies. So there's not really clear sex differences in normal cognitive aging, but there's certainly sex differences in dementia risk. There's a question about are you aware of psychological research investigating expectancy effects? Also, any views on systemic influences media portrayals of older? There is of older age, aging, etc. So there is certainly work around how ageism influences various health outcomes. That, to my knowledge, I don't know about cognitive outcomes. With aging effects, it's really difficult to separate perceptions of aging from actual aging because aging is kind of the biggest driver of cognitive decline. So but there's certainly a lot of work around ageism and various health outcomes. About hearing. So this is actually a really important one. Any recommendations, recommendations, comments about hearing? Um, so um, yeah, so hearing is actually a really important risk factor for dementia and it's getting a lot of attention right now. So it's thought that addressing hearing impairment in old age could be very helpful for preventing dementia. The idea is just basically to get hearing aids if you need them, because the idea is it's um, either hearing loss is occurring due to the same causes that are driving the dementia problem, or it's because you basically become more isolated and you have less cognitive stimulus, and as a result, your cognition begins to decline faster. So either way, the recommendation is to have your hearing regularly checked and get hearing aids if needed. So I see what is the age range for midlife? When do cognitive abilities peak? The age range for midlife technically is around 40 to 64 years. What we see is cognitive abilities, depending on the domain, because once again, it's extremely domain specific. Cognitive abilities start to decline from age 45 onward in some cognitive domains, but it's not, but the real decline doesn't start to accelerate until much later, until sort of age 65 and above. And until that point, you're kind of accumulating cognitive abilities, and so that's when you're kind of establishing what point you're going to start your decline from. Go back to the top here. So there's somebody said, you mentioned alcohol as a negative factor. What about drug use? There's not as many studies at the moment, at least the sort of large scale cohort studies that I've seen that assess drug use with respect to cognitive decline. I would assume it is it's not good for cognitive health because obviously it's not good generally for health in general, but I wouldn't want to comment on it without being more aware of the literature. Okay, is there any evidence that other inflammatory conditions like arthritis, Crohn's, ankylosing spondylosis are associated with increased risk of dementia? Yes, there is evidence that inflammatory conditions are related to dementia, and this is one of the links that is being researched quite a bit right now because some of what we traditionally thought is causing Alzheimer's disease doesn't necessarily seem to be a cause of Alzheimer's disease. So there's a lot of research about inflammation and the role of inflammation. He says, you stated what about the use of Ozempic or Mounjaro with respect to cognitive function? I think these are, because as I said, we need to look at these changes over really long periods of time. It's just too new to have any evidence at this point. It will be interesting to see, because of the beneficial cardiovascular effects, if it's potentially protective against dementia. I think that will be something that will be very interesting. Can the brain, oh, sorry, these are sort of refreshing as I go, so they occasionally disappear. Let's see. Yeah, so here's a question, which is, are there any studies on high performance athletes around this, as in does pushing themselves to the limit for a long period actually reduce the benefit of physical activity on preventative cognitive aging? As with respect to cognitive aging, whether there's sort of a threshold effect, I don't think there is some evidence I can recall suggesting that there might be an amount of physical activity that's too much. But I think the issue here is that this is generally the people who are the vast majority of participants in these studies who are age 50 and above aren't doing that kind of intense physical activity. So it'd have to be a very sort of specific cohort of people to be able to answer that question. And I'm not sure if it's really been done. For other benefits, there's certainly some evidence, other sort of general health outcomes, there's some evidence to suggest that there is too much physical activity you can do, where you can start to sort of cause your body to break down. Let's see. Okay, so what is your opinion on the relationship between SES and modifiable lifestyle risk factors? How do we disentangle the effects between affluence, better access to healthcare, and other protective factors that may be hiding behind healthy lifestyle? So that's a great point. So we think of sort of things like SES, so your education level, your wealth, your income, all of that. We think of those as sort of causes of causes, right? So they contribute in large part to the kind of lifestyle that you have. And that doesn't mean that by affecting lifestyle, you can't necessarily affect cognitive aging, but it means that you also need to be thinking about more systemic inequalities and how that contributes to the sort of patterning of behaviors that leads to cognitive aging. So it's something that absolutely needs to be taken into account. And there's a huge amount of work around sort of socioeconomic inequalities and cognitive aging and how those drive all of these other inequalities. There's a question, if you have been a poor sleeper all your life, do you think it is worth trying to focus on improving this, or is your typical sleep pattern just one of those genetic things you live with? Um, so yeah, so this is a tricky one. I think sleep is very important for a lot of reasons, not just cognitive health. It's important for yeah, for a lot of different health outcomes. Um, to the extent to which you need a lot of sleep definitely varies a lot between individuals. There's certain people who thrive off of maybe 4 or 5 hours of sleep, but the vast majority of people need kind of 6 to 8 hours of sleep. So it is something that's uh, worth addressing. It's if you can. But once again, as I said, it's as part of a healthy lifestyle. So if you can kind of if it's sleep is something that's hard to improve when it's not good, and so if you can kind of maintain your other behaviors and try to have as healthy lifestyle as possible without sleep, and then do your best to kind of improve sleep hygiene and to the extent address it that you can. Yeah, I do think it is worthwhile to address. So there's a question, any research on perimenopause impacting on cognitive aging? So we do see that we do know that estrogen is associated with better cognitive performance. So we know that people's cognitive abilities can decline a little bit post-menopause. And as I said a bit earlier, that's one of the things that's thought to maybe underlie some of these connections between dementia and the fact that we tend to see dementia more often in women. But it's sort of it's challenging because there's sort of like hormone replacement therapies are not necessarily protective against dementia. So it's not a straightforward relationship, as none of these things are. So it's a little bit it's not straightforward. Um, So the next one is these lifestyle factors are, of course, individual, but we also know that a healthy society can help individuals make good choices. Robust. Okay, so yeah, so I kind of talked about this a little bit earlier. Definitely very robust relationships between all of these markers of inequality and dementia risk. So it's in fact, education is among one of the strongest and most consistent associations, sort of like with dementia risk. So yes, so we know that this is causing probably a lot of the because if the other thing is if we look at a lot of the midlife factors, all the midlife risk factors for dementia, those are all things that are socially patterned, right? It's all about health, it's all about obesity, diet, etc. All of these things are socially patterned. So we know that sort of inequality, socioeconomic inequality underlies a lot of these relationships. Um, the next question is HRT protective? So yeah, so I got into that a little bit, but basically it was seemed to be really promising. And then there was a major study that came out about it and actually changed some clinical practice. And then it turned out that that wasn't necessarily the case, and they hadn't accounted for some important things. And so now the thinking is possibly it is protective, but possibly only while the neurons, the nerve cell, the brain cells are still healthy, or there might be some kind of caveats to when it is or is not protective. So yeah, so right now the evidence is mixed, unfortunately, as it is for a lot of these things. So is continuing to work protective from cognitive decline? There is some evidence that retirement is associated with a reduction in cognitive performance. It's very hard to separate that from an aging effect. There's also some evidence that finds if you are sort of cognitively stimulated in your retirement that you don't have as much, that you perform a little bit better. So once again, mixed depending on the study question. Unfortunately, that's going to be my answer to a lot of these questions because the research is genuinely very mixed. It's very complex. Okay, let me sort of go to the top again here. Let's see. So there's a question. Music seems to stir memories to a great extent. Is there any evidence that participating or listening to music over the life course helps maintain cognitive abilities? That's a really good question. I recall seeing sort of a pilot study where they had uh, linked connected older people experiencing some cognitive decline with younger people and to do music, which was really lovely from a certainly I think I don't know if there was sort of a clinical benefit, but it was certainly really lovely from just a well-being perspective. There's a bit of evidence to suggest that Alzheimer's disease, for example, isn't as detrimental for areas of the brain related to music, which is why you have a lot of people who maintain their sort of musical facilities much later than some other skills. But to my knowledge, I'm not sure about whether there's evidence specifically about music listening or over the life course. It's a really great question. So socialization is the way of reducing isolation from society. However, interaction with other people can be a great deal of stress as well. In terms of prevention of dementia, early stage cognitive aging, how can we make balance between the two aspects? Okay, so that's an interesting question. So actually, we do sort of delineate between these things in research. So we look at social isolation, which is just to do with the number of contacts that you have, and loneliness, which refers to your subjective feelings about how connected you are to other people. Um, and um, and so basically sometimes you do see slightly differing relationships between because some people are sort of alone by choice versus if you're don't have a lot of social context and you're not lonely, that might have sort of a different a different effect on various health outcomes. So yeah, definitely there's evidence to suggest that the quality of your social support matters, and so you shouldn't be it's not that you should just have more social connection for the sake of having more social connection. It should ideally be something that does reduce your stress and and brings you happiness. There's a couple questions about twin studies. There are twin studies around mostly to do with heritability of cognitive function and cognitive performance. I'm not sure about dementia risk. I would imagine that there are, but I'm not familiar with them. Statins and dementia, there is a lot of work around statins and dementia because blood pressure is a pretty robust connection with dementia. Um, let's see, the role of environmental toxins in contributing to cognitive decline and elevating risk for dementia. So this is a good question. So again, this is an area that has limitations in the body of research. In general, we see that environmental exposures like pollution are associated with increased dementia risks, worse cognitive performance. Um, the extent to which these sort of very sort of distal environmental exposures affect your dementia risk and your risk of cognitive decline compared to things like your health and other things that are a little bit more individual. It's relatively small, but it does contribute to this entire picture of what shapes your cognitive aging and dementia risk. So there's a question, is there research linking social inequality, health inequality to declines in cognitive function? So I have kind of answered that. There's a huge body of research. And what study methods can establish the direction of causation? So this is a tricky one. So one of the best ones we have is, as I mentioned, if we sort of assess something in midlife and then we look over a very long follow-up period, that works well for dementia as well, because if we sort of are 20 years before dementia diagnosis is much less likely to be affected by early symptoms of dementia. There's also specific study designs where you can, or specific sort of analytical techniques where you can look at both directions of the relationship. So you can assess to the extent that one affects the other, and then or the extent, for example, of physical activity in dementia, let's say, you can look at the extent to which physical activity affects dementia and the extent to which dementia affects physical activity. There's other studies. There's studies that are sort of use. I don't want to get too sort of technical into it, but maybe you can sort of look it up. Things that like instrumental variable approaches, which kind of use a third variable that's not related to dementia, except through physical activity, for example. Um, and so there's a lot of different study designs that we use to kind of get at some of these direction of causality questions. But ultimately the issue is because we're observing people, we're not assigning people to, smoke or not smoke. We're always going to have some of these problems in this area of research, and we just have to sort of amalgamate as much evidence as we can with as strong as study designs as we can that are feasible to try to understand what's going on. Okay, so I'll do a little refresh and see if there's. So there's a question about meditation. I think there are a couple of studies out there, but I would say the strength of the evidence is not overly strong. I'm trying to see if there's any. How is Parkinson's disease related? So Parkinson's disease can cause dementia, but is a distinct disease process from these other dementias. So from, for example, Alzheimer's disease or vascular dementia. There's a question, do we need volunteers for further research? Certainly you can look into there's a lot of these large aging studies that will be recruiting participants mainly over 50s. There's some smaller sort of pilot studies that will be recruiting. So if you sort of pay attention to UCL listservs and that sort of thing, we're always very interested in having people participate. So there's a question, can the brain create new brain cells as the brain ages? In general, no, but there is, but as I said, the brain has this immense capacity um, to form these compensatory networks that sort of get around some of the issues of brain aging. So we see that people just get much more efficient with how they use their brains because you kind of prune away the pathways that you don't use anymore as you get older. But that doesn't mean you're able to function less or anything like that. It just means that your brain gets really good at the tasks that it can do and is able to compensate for some of the changes in brain structure. Um, for evidence for biological sex bias in relation to cognitive aging overall or in relation to any of the specific risk factors. So I talked a little bit about sort of inconsistent sex difference in cognitive aging versus the fact that we see more dementia in women. As to whether if there are risk factors that actually affect men more than women or vice versa, or males more than females. Um, there's a bit of evidence to suggest that education is more beneficial for women, and you see that a lot with health outcomes. And the reason is because the thinking is that sort of men have more other resources to fall back on, whereas education is sort of more important for women. Or so that you see that kind of relationship with a lot of health outcomes, including cognitive aging. So there's a question is, what is the main pathway mechanism of action for the effect of cognitive health on behavior? Memory. People are forgetting to exercise. So that's a great question. How are these lifestyles then feeding back to affect cognitive health? So the thought is that doing for physical activity specifically, doing physical activity requires planning. It requires remembering to, it is just remembering to do it. It requires a certain amount of sort of activation energy to be able to do and motivation to be able to do physical activity. That might decline to an extent with cognitive aging. The other thing is that cognitive aging can be related, or sort of cognitive decline can relate to your ability to kind of do basic tasks, to move around, to go out, to do all these things, and that might restrict your ability to do physical activity. It might cause you to become more socially isolated, which can give you fewer venues to do physical activity. So there's a lot of different ways it's thought that it might impact physical activity. It also can just be commensurate with you becoming older, becoming sort of experiencing frailty and that sort of thing. How much alcohol is excessive? Generally, I believe it is, I don't want to quote off the top of my head. I think for the NHS says, it might be, I'm not going to say because I don't want to, I look it up on the NHS because I don't want to quote incorrectly. Do your comments relate to all dementias or just some? That's really important. So it's difficult to distinguish between dementias in this kind of observational research because otherwise we'd end up with really small sample. Well, we'd end up with primarily Alzheimer's and then and vascular dementia and then not as much for the other type. So it's likely that a lot of this research is primarily relevant to Alzheimer's and vascular dementia, and these other dementias might have some slight differences in risk factors. So it's important to keep that in mind as well, is that the vast majority of observational research is gonna concern vascular and vascular disease and Alzheimer's. So there's a question about, well, I guess this is sort of about social isolation and loneliness once again, and I might be kind of running out of time a little bit here. Oh, um, I might have just run out of time. Oh. So there's a question about if you do not feel lonely, and that's kind of what I was talking about before. If you don't feel lonely, but you are alone, um, and um, and whether social interaction can also be like actually interacting with people. So speaking with other people, being cognitively engaged can also help your cognitive decline. And that is another, I mean, it's another consideration is sort of the cognitive stimulation of uh, the cognitive stimulation of communicating with other people. And so that is something to consider with, even if you're alone but not lonely, that you're having other avenues where you feel cognitively stimulated is important. Okay, so I think that's the last one I probably have time to answer. Thank you very much for all of your questions. Yes, I think.
Oh, thank you so much, Mikaela. I think you probably win a record for the number of questions you managed to answer in the Q&A. That was absolutely amazing. You got through so many questions, so many great questions as well. So I just wanted to, just a few words before everybody heads off. Just wanted to say thank you so much, Mikaela. Honestly, your presentation was wonderful. I know you're going to share the slides with me so I can forward them on to everybody along with the recording later this week. I just wanted to thank everybody as well who for joining today and for all of your questions. This is the first event of the 2025-26 academic year. So we're currently working on the programme for the rest of this term. So do keep an eye out on the UCL website as well as in the alumni newsletter. So we'll share more details as soon as they're available. Finally, we'd love to hear how you found today's event. So on the screen, you'll see a QR code. Alternatively, in the chat, my colleague Tim has shared a link to a feedback form. It's just should take only 5 minutes or so. And we'd really appreciate it if you could just spare that time to let us know how you found today's session. And we'll also send the link out via email as well. So don't worry if you don't have chance to note it now. So that just leaves me to say a huge thank you once again to you, Mikaela. And thank you to everyone for joining us today. We look forward to seeing you at another UCL Connect session very soon. Thank you so much.
Thank you.